and from now on, whatever we write on the blackboard shall be registered. I think we shall have one small movie of, let's say, as our rector suggested, 30-35 minutes, because via internet, the didactics here is more intensive. Therefore, we shall have 30 minutes, then small break of job or something this type, and then again shall start the registration. Therefore, who is following can have these small breaks in order to go. Now, as I promised, first let us show again, because there are some new participants of our course. Let me show you the homepage of our course. My name with Pisa, and then immediately appears the homepage. Teaching, this is Mathematics for Neuroscience, is our course, the homepage. I am preparing, as you can see, lecture notes. Most of them there actually, but before putting some part of the lectures, let us have a little bit lectures and exercises. By the way, do you see no, you cannot see my homepage. Do you see? Pronto?
No.
Yes. Okay.
No,
Let us check now. Please, you switch at any moment your microphone and see. We are a small group, therefore no problem. You can now. I start to share because I forgot to share the screen, and let us show you our homepage. Now probably you can see.
Yes.
Can you see? Because switching from the chat is more difficult, probably is better to say me. One confirmation is okay for me.
Yes, we can see it.
Okay, okay, very good. So as you can see, there are some lecture notes that are in preparation. I shall put them and shall put them here, while the registered lectures shall be in our YouTube channel. Another thing that I wanted to show you from the very beginning, since we are there are some new participants, is our Teams room. As you can see, this room, we have very simple structure, Generale, and in Generale there are, how to say, messages or events that we are doing. I want to stress your attention to this part. It is called Attività. Attività, for example, means the following. Start, and I create Attività. So what I can do, for example, we decide to have written exam, exam 1. Then here I shall put as a task file, short PDF file with the text of the first exercise, because this, the first activity shall give you one concrete problem. And then I can plan when this event will appear, when your work will start, and when you enter, you shall go to this section, Attività, And from here, you shall take your PDF with the test of the exam. And then you can, usually one exercise means 1 hour work. This is typical. In this way, you shall not be very tired. You can prepare your answer, and then you can put in the same place. For example, let me show you, for example, with other students that we did such exams. For example, this is one course in the last semester. As you can see, this is assignment, prima parte. Let's see what happened here. Here, have each of these guys who participated. For example, when I put here, I can see his or her solution. On the right-hand side, I put marks and then eventually my vote. Therefore, at the end, it should be very simply, and we shall make simulation of these exercises so that you can really, during the course, have kind of exercises, possibilities to do practical work. Okay, this is for our homepage, why we have chosen this team, that is official team of our course. And this is one of the most important points, attività. There is a possibility also to put some files, but I prefer to put in my homepage and to use YouTube, because YouTube gives you more possibility to follow more easily. Here the traffic is much better, while this team platform had really difficult problems when all students had all lectures on this team platform. Okay, now for the moment stop and again ask you if you have some questions with connected with what I showed you till the moment. At any moment, again, if you have some not clear moment, as I told you, we shall have simulation. Therefore, many details we shall, as today, when we started, we had some time for preparing the bureaucratic, how to say, to the technical part. And now let's show you one important place in internet where you can find really very simple software, such that if you take a guy from the street for 5 minutes without learning new languages, he or she can start to solve some of the problems. Let me recall you that in the last lecture we had a problem with one integral. Integral this over sine of x, and we did hard work to solve it. Now let me show you this magic homepage, which is Wolfram. I don't know if you know this homepage, Wolfram Alpha. So here is something very simple. In your line, you put the integral you want to calculate, or you put the equation you want to calculate. Then this guy is making the calculation, numerical or analytical, as you did, for example, by hand. In mind that there is below some help, but since I have also the program here, we shall put exactly, as you can see on this line, the command is simple. There is a help, and if you put in the help name integral, immediately appears this line. So I do not learn any language. I only copy it from this command. So let us take this command and put in the home page of Wolfram. And at the end, let us put equal. Therefore, we are asking the guy to calculate. Accept cookies, okay. And as you can see here on the right-hand side, there is the answer. So what actually we couldn't do till the end last time, here you have exact solution. Cot means cotangent. Cosecant means 1 over sine of x. So with a little bit small work, you can use this software, and we shall see that when we study models where we haven't exact solution, this is quite helpful for our numerical approach, for numerical calculation, numerical approximation. So if you don't mind, I shall put inside our, I think this was the main page. Okay, let me put in the home page in our where was our meeting? This is Teams. Okay, stop sharing. Okay, we are here, and in the chat of our meeting, I shall put this address. Let me ask you if you can see the address that I put in the chat of our lectures, of our lecture today.
Yes.
You have this. This is the address. Therefore, when we need some numerical or some pictures, we can use this thing. The only thing, still we shall do some examples to have a little bit abilities to compute, to calculate the integrals, and therefore to know what the computer, the software is doing. So from now on, if you don't mind, I shall switch to the whiteboard, not blackboard, and we shall continue examples of differential equations and models of simple models of differential equations. A small preparation is needed. Okay. I think now we shall clean. The simplest Malthus model of increasement of population is connected with very simple ordinary differential equations. Namely, equation, we continue to work with differential equations and models. And as first example, please to tell me if I go outside and you cannot see me. Therefore, I show a little bit for the moment. I think can write from here. up to here. Okay. If I am outside, please to tell me. So let us start with this simple equation equal A epsilon. Of course, as the last time we mentioned, epsilon is a function of t. And here A is a constant. If we want to consider the Cauchy problem, then we shall say that in the moment t equals 0, for example, we can put B, which is number of habitants in concrete place, in the moment t equals 0. Then the increasement of the number of habitants is measured by, modeled by this Cauchy problem for our solution. How we can find the solution? It's quite simple, following the procedure of last time. We represent our first differential equations in this way, putting here indefinite integrals, and then we use, we said from the table in our lecture notes, we know that primitive of 1 over epsilon is logarithm. Therefore, from here we get logarithm of epsilon is constant A out the integral dt is t plus constant. So we get at is primitive of this constant, and we shall not forget always when we use primitive these indefinite integrals, we have to put here the. This relation enables us to express epsilon t as function a to the at plus c. Of course, I can use the rule that a on exponent something plus another thing is a to the power at times a to the power c. And for this, we can say that essential part of our solution is here, because this is exponential function, and clear that it is increasing very rapidly exponentially. Well, this is simply one constant. To have simpler notations, I shall replace this constant with C1. A to the power c is again constant, so we can clean this part and say that our solution is this one. What we know, what we are looking, we know the generic solution expressed in terms of this constant, but we want to connect this constant with our initial data. So I shall take this expression, shall put here, therefore shall substitute t equals 0. But if t is 0, epsilon of 0 is a to the power 0, that is 1. And therefore, we shall get the relation C1 equal B. This is our calculation epsilon 0, involving the constant, the parameter from our equation, and B is the data that are given. Therefore, now we can find our solution, that is b a to the power a t. This is solution of our problem, and this shows that if a is positive, which is the case real models, then the number of the population is increasing exponentially. Formally, if a is negative, it's clear that we shall have a function. Actually, this is perfect model without any disease, without any additional factors. If we want to add additional factors, model connected with situation more clear, more close to a real life situation, and instead of one unknown function epsilon, we can say epsilon, for example, if we consider the cells in some organ as health cells and ill cells, contaminated cells and health cells. There are two unknown functions, and in order to have a good model, we have to write differential equation involving two unknown functions. And we shall say that this shall be one of the most important directions in our course, to find different models connected with two unknown functions, because in this case we can do many things involving also Wolfram alpha software. We can, even if we cannot solve explicitly, like in this case the solution, we can somehow obtain really very nice and exact, precise numerical results. Okay. Now let us turn to the other example that we had before. Yesterday and today our first example with Wolfram alpha was connected with this equation, zeta prime of t equal sine of zeta, and zeta 0 equal, for example, let's put some number. And again, for determinacy, if you don't mind, put the same initial data. 1. So the solution shall be 1 here. What we have here? Two different concepts. Here I use the letter epsilon. I can use any letter. In particular, we can use the letter zeta. This simply indicates that we have two different equations, two different solutions. If I put here epsilon, of course, if you have a little bit experience with treatment of differential equation, this is also possible. But for the moment, I prefer to use different letters to separate the meaning. Here we cannot have so simple solution because repeating the same strategy, this equation is with separate variables, so we can apply what we did in our first lecture. And the green one means that we have to take the zeta, this is not good, over zeta, no, over sine zeta. This should be my first mistake too, but not, it is sine of zeta equal integral of dt. And this was the example we started last time. Now, with the help of Mathematica, why I am calling Mathematica? Mathematica is the software, but all this language that is connected with possibility to use this software is called with the name of Wolfram. Therefore, Wolfram alpha, this is public, how to say, way to use this part of this software. If you have more complicated problem, that it's necessary to have paid version of Mathematica, and therefore you have more powerful software. But again, our purpose is to have the basis and then to meet some mathematician and ask him to do this job, and then of course you shall have also possibility to understand the result of the mathematician when he shows you or she show you the some tables or some graphics. You can understand much better. Now I shall use Mathematica. I am very lazy, and therefore let us see what gives me Mathematica. Integrate 1 over sine of x. It's simple. I am writing the result. So here the answer is minus logarithm. No, it's not writing well. Here it is. Even without logarithm of what? F 2 sin x over 2 divided by, yes, cosine x over 2. Cosine x over 2. So this is our integral. Of course, we shall not forget to put plus constant. Okay, so here we are lucky. We skip the I take. Here is zeta. Here I put x because I looked on the. This is not zeta. This is my mistake. And please to stop me anytime you find a question and or some. Especially I had this practice with all other courses because I had courses for almost 15-20 years, and whenever the student finds essential mistake in my lecture, put a red point. This means at the end of result of written exam, for example, if she or he has 20 points, I shall put 21. If he finds 3 essential mistakes in my lecture, then the student will have 20 plus 3 points, 23 points. Therefore, we will increase initial average for the oral exam. Okay, now we have this equal t. I don't write here constant plus c because already the constant is here. I shall put my constant on the right-hand side. And then from here we can find tangent of over 2 is a to the power t plus c. And from here you can press your solution zeta, solve this equation, and find zeta is 2 times arctangent. This is the inverse function of the tangent to this equation of a to the power t plus c. This is our solution. And as you can see, this solution seems, despite of the fact that we found it, is much more complicated, especially if you want to draw the picture of this function. While for the blue, we could very simply, knowing that solution here is e to t, a to the power at. This function is much more simple, and we can draw very easily the picture. The picture here shall be, roughly speaking, the following. So here is t, here is epsilon. Hope you can see this part, okay. And when t is 0, we start from 1. I want to draw the graphic of this function, and it is clear exponential function that even the high school students know very well. This function arctangent of a to the power t plus c is much more complicated, and that's why here the graphic function is much more simpler. We have exponential increasement. Here instead, we can say the following. What will happen when t goes to infinity? When t goes to infinity, this grows exponentially. Can we predict what will happen when t goes to infinity? Here we have a to the power infinity plus infinity. What is arctangent plus infinity? Let me see if you can help me. Arctangent, we shall draw of course, the picture, but arctangent of plus infinity, what is the result? If you have some suggestion, let me recall you how the graphic of arctangent is obtained, as probably this was done in some of the previous years when you had mathematics, even in the high school, but let me repeat. This arctangent, because in general the students have always some difficulties with sine, cosine, tangent, arctangent. Therefore, it is important to have knowledge of the behavior of some elementary functions. This shall be helpful. And if you have some difficulties, please to tell me this function I want to understand better, and we can turn back. But this function is very important because shall give something completely different. And as I told you, this problem, the green one, is connected with Kuramoto model that is connected in neuroscience. Kuramoto model is very important. And in this case, models interaction of two oscillators. Therefore, it is important to know if your sleep, for example, is disturbed, and what will happen after a long period of time, t very big, how this practically cycles REM, no REM. We shall see this in the next a little bit further. But we shall have the necessity to have really precise study of the solution, and in this case, the graphical function. Now, let us start with this function. This is x, and this is tangent of x. What is the graphic? It is quite simple, because we know that tangent is sine over cosine, and here we have minus p over 2, and p over 2, where function cosine in denominator goes to 0, and therefore we have here this behavior. In 0, tangent is 0, and then we have this behavior. Therefore, this function is defined except some points where cosine in denominator. And we can say that if I write epsilon equal this guy, arctangent shall be x. Arctangent arctangent of epsilon. This is by definition the inverse function. Therefore, what I have to do is to make a rotation of 90 degrees in such a way that this will become horizontal and this will become vertical. Let us see the graphic of here we take epsilon, and this is epsilon arc tangent of epsilon. Now, here in 0, we know that x and epsilon are 0, so this is our starting point. Then, when epsilon is growing, we see what happened with x. For example, if I am here, my is closer and closer to p over 2. When epsilon goes to infinity, my value on the graphic is closer and closer to p over 2. Therefore, if I want to make the picture, I have to do like this. This graph approximately goes to p over 2. And of course, here we have the same with minus p over 2. Therefore, now you can immediately answer what happens with this function when arctangent of something that goes to plus infinity. Of course, this goes to p over 2. And as you can see, this picture, of course, here I have to replace epsilon with this parameter, and this picture are completely different. In the blue one, the solution goes to infinity. In the green one, the solution remains only always bounded, and we have really different behavior of our solution. Somehow, we shall see in our next lectures that we can do something that shows similarity of our solutions only for small times, only for values of initial data close to 0. But this shall be done in our, shall be discussed further. Today was important to show you two similar examples and show that geometrical representation of the solution is very important. Now, let me for the moment stop. For the moment, I know that probably listening, you haven't in the moment many questions, but let me leave a little bit time to your questions to see if you have some doubts, questions, or remarks. Probably some of you already know very well this function, but for completeness, I prefer to give some idea more precisely for everybody. Now, if you mind, we shall stop for the moment registering the lectures. Or again, you can think a little bit. I shall go outside in order to save, shall go outside our meeting in order to save the part that we did till the moment. And in 5 minutes, we shall continue with short lecture, how to say, something like not more than 25 minutes to half an hour in order to continue further our study. Okay, so see you later. I'm stopping registration.